Alright, so we're doing heat maps again today, at least for part of the class. Because in Discord, some of you said that you want another example for heat maps, so we're going to do that. Forgot to upload the file though. It's a new file. I asked some of you guys what kind of stuff you wanted to look at. Hold on. Where did I put it? Here. Alright, so I asked some of you guys what kind of data you wanted to look at. And I got mostly like sports suggestions, which are good. I like sports, but finding the data itself is hard. So for some things it's hard, and I know for the baseball data, I could just go to Baseball Savant. That's where I always get all of the data from. So it's really easy that way for me. So that's what I did again. So we're doing baseball again. Sorry, it's going to be home runs by year. So I'll show you what that looks like. Let me put in the file here, because I forgot to before. And then you guys can get it right now. It's available right now. You just saw me upload it. It's under files and then data if you want to go there. Or if you want to go on today's page, now you can go on today's page. Alright, so this is what it looks like. So basically it's sorted by team and sorted by year. And from that, we kind of can get a matrix of data for year by year and then team by team. And then we can plot that as a heat map. And so I think we'll do the heat map first, and then after that, we'll go over the code for project 1. But I want to make sure that we go over the heat map since that's more immediately relevant to your project. Alright, so let's go over here. Reset this again. Oh yeah, I guess before we get started, are there any questions on the class or... Oh, I didn't even talk about the project, huh? Project 1, your grades. Let's talk about that. Let's go back here. Okay, I'm going to stop sharing, so I'm going to check the grades really quick to look at the average. Project 1. Alright, so the average is a 74.44%. Someone asked, I don't know, you guys could see the high. Someone asked, how did someone get a 101? Because their report, I think it was their formatting, was not to say everyone else was bad, but their formatting was by far the best. It was so good, so I gave them another point. And everything else, they got 100, so. Alright, so yeah, the average 74%. And so if you have any questions on the grading, you can talk to me about it. You can send me a message on Discord, or we can talk about it, over Zoom or something. Got to schedule a time though. So it's pretty good though. A 74% average is good. So, I don't try to have an average like that, but that's where it went. So that was a good average. A lot of you guys got A's. There was actually a decent amount of 100s on the project too. So if you didn't do as well, let me turn this down a little. If you didn't do as well as you thought you were going to do on the project, it was probably from the write-ups, or you just didn't get all the graphs, but most likely it's from the write-ups. So that's a big portion of the project. You need to make sure they do. For the first project, it was doing write-ups for all of the code, so you could make a plot for all of the figures. Okay, so yeah, the write-ups, that's probably the main thing where you lost points, or the figures. If you just weren't able to get everything running smoothly with your code and you couldn't generate all of the figures. Alright, so question, what was last semester's average? Let's see, I'll actually check really quick. I'm gonna stop sharing again. Let me check. We have some time because today's gonna be pretty relaxed, just the heat mapping and then project one. Go to my dashboard. I think it was around the same, but let's find out. Project one. Alright, so last semester was actually lower, and no one say it, but last semester it was an average of 69% for the first project. And then I think, let's check the second project too. So you guys did better this time around. In the second project, second project was worse. I guess I remember wrong. So second project was 66%, but that's, some people didn't turn in the project at all, so that kind of skews the average. If you did it for people that turned it in, it would be higher, of course. And then the average for the class, I forget, and on Canvas, oh no, I actually can get to it somewhat easily. They have it in a weird spot though. The average last semester for the whole class was a 73%, so still reasonably good average. I'd like that to be higher though. I mean, of course. But you guys, you're looking good. So the average was 74% on that first project, and for the class right now, the average is really good. The average for the entire class is 82%. Yeah, the average grade, overall grade for last semester was 73%. Right now, you guys are at an 82%. I'm not doing anything different. It's not any easier or anything, but you guys are doing well. So it's good. I also updated the grades where, I dropped the lowest quiz. So that's actually implemented right now in the grades as well. 73 is, like I said, I'd like it to be higher, but that's a pretty standard average grade, especially for an engineering class. But yeah, I'd like it to be higher. And again, that's skewed too from people that just stop turning stuff in from at some point in the semester, because that did happen. Okay, let's go over this baseball stuff. Okay, so you could get the data from online now if you want to do it, or you could just follow along by watching. Alright, so we're going to be making this heat map here. Alright, so this is sorted by team and then by year for the amount of home runs. Or I shouldn't have said it like that. So this is the amount of home runs per year, per team, and it's sorted by 2021 for who currently has the highest amount of home runs. So I threw that in there because, again, you guys are going to be sorting stuff for the project. Oh, oops. Thank you for telling me. All right, there. Now you guys can see. All right, so this is what we're doing here. We're making this heat map. We have the years down here, and we have the teams here. And we're going to be doing the amount of home runs per year per team. And then it's sorted by 2021 over here for who currently has the most amount of home runs per team. All right, so we're going to do that. And you can see, look at 2020 because of COVID. All right, let's make a new script here. I'm going to copy and paste some of this just because it's, I don't want to go over the really basic stuff again. All right, so the first thing that we did here, we imported the data, which of course you know what to do. And also on the same line, I actually sorted the rows as well, where I'm sorting it by the column that's called year, and then I sort it by ascending. So it's going to start at year 2008, and then it's going to go to 2021. All right, so you can do all of that on one line of code. All right, next thing, we got the unique years because we want to have those unique years on the bottom of our heat map. So we found the unique years here. So that's 2008 to 2021. And then we looked at the unique teams as well. And at the same time, I also converted this into a string because later on, we're going to be using logical operators. Someone remind me if I forget. After we go over the heat map, I want to talk about the project again, project 1, for what people specifically missed points on. And one of those things I just thought of it now is explaining why we convert a cell array to a string array. So we do that, at least for this project, to use a logical operator later on, which is equals equals. So it has to be a string array. Okay, so I'm combining that, I'm converting the cell array to a string array, and I'm using the unique function to find the unique players that, or the unique teams that we have, which is in this column here. It's called player ID, but this is the abbreviation for the teams. All right, and that looks like this. So we have 31 teams here, but there is something that's a little funky. On 11 here, you see Florida. That's the Florida Marlins. So the Miami Marlins, they used to be called the Florida Marlins, and then they became the Miami Marlins. You'll see that on 16 here. So we have to combine those into one cell. So we're going to do that by doing concatenation, which is what we talked about kind of a while ago. We're going to do that. So I'll go through that kind of stuff a little faster, just so we focus on the for looping and then the heat map, the more important thing. So the for looping, all we're going to do is find the indices for each team. All right, so we have for I equals 1 to length of team. I want to loop through for every single team. For I equals. Oh yeah, comments. You guys did pretty good on comments in the project. Some of you should be using a little more, but it's actually really good in general. So I'm happy to see that. Okay, so we're gonna say find indices for each team. So yeah, if you guys keep up for project 2, if you do just as well, you know, I'm not gonna grade harder or anything. I'm gonna grade the same. I'm not trying to get any specific average for the class. Then the average is gonna be real good, which is good to see. All right, so team IND. We're gonna make this a cell array. This is another thing for the project. Some of you used a cell array, but you didn't explain why you were making a cell array. So we're going to be making a cell array here because actually for this in the end, which I guess a little ironic, but in the end, this is actually going to be the same amount of data, so then I'll change it. But if you use a cell array in MATLAB, typically you're using a cell array because the lengths are going to be different for the arrays that you have. So if that's the case, then of course use a cell array, which is often the case with indices. For project 1, I don't think it was the case, but for project 2, it will be. So for some of the things that we do. So some counties, they didn't start their vaccinations at the same date as other counties, so their amount of indices are going to be less. All right, so let's do, for now, I'll just do this. So team ID, find when t.player ID, and that's going to be equals team of I. All right, and we'll say end. Okay, so we're looking at our column here called player ID, and we're saying find when that's equal to, so now we're going to loop through this string array here. Find when it's equal to some team in here. Again, then we're going to get all of those indices. So open team ID. This is just, so this is just going to be a vector right now. Let me run my script over here. I made this script a few different ways yesterday, so I want to make sure that I'm doing it how I think I'm doing it right now. Team. Let's open it up. Okay, I do have it like that. Let's move it down here. Okay. Okay, I'm going to comment this out first. At some point, I had a kind of like a matrix, which is what we want in the end. Okay, so it's good so far. I'm gonna leave it like this for now, but this is another case of do as I say, not as I do. I didn't initialize this array. Let's do it now, actually. So initialize array. You'll see in the project, and I do this too, to be honest. Sometimes I don't initialize the array in the beginning. Technically, you should, but you can generate it, and then you know for sure what size it is, and then you can initialize the array. But really good practice is to initialize the array beforehand. So we have team ID. Currently, this is a cell array, so we're going to say cell. And we want 1 row and 30 columns. 31 columns. Let's comment this out for now. Run. Oh, I need to use regular parentheses here. And then the mixer cell array. All right. Okay. Now let's go on to the next part. So again, we had Team 11 and Team 16. That's the Florida Marlins and then Miami Marlins. They should be as one. They should be together because they're the same team. They just changed names at some point. All right, so we're going to go over here, make another comment, append Team 11 to Team 16. So I want to put, I want to move Florida Marlins. Geez, I almost said Dolphins. The Florida Marlins into the cell for Miami Marlins. All right, so that's going from Team 11 to Team 16. Also, your comments in your project, they shouldn't be extremely long. Comments in a script, they should be short and succinct, and then your write-ups, that's when you go into detail. If you're looking at code from someone else and they have really long comments, that just makes the readability harder in the code. They should be short and succinct. And like, so you might see like a research paper or something, there's an associated script and they'll have comments in their script, but in the research paper, they'll break down the code in more detail, kind of like we do in our project. Okay, so let's modify the 16th position, and we want to use our concatenation command. So we're going to say cat1, and that'll append stuff below. So we have cat1, comma, team IND 11, and then team IND 16. Okay, so I want to have the indices for when they were first the Florida Marlins, and then I want to have Miami Marlins. Okay, so now if I run this, so this ran, and our last value now should be empty. Did I not run it? Or maybe it's over here. Let's comment this out. team ID 16 is, yeah, 14 by 1. Okay, but and before it wasn't. Is this one? No, that still has stuff. So before team ID 16, that shouldn't have been as much. Yeah, okay. So before there was all of these, it wasn't 14 by 1. Now if we concatenate the Florida Marlins in cell 11, then it goes to 16, and we still have stuff in 31 because I didn't delete the cell yet, that's why. Okay, remove the cell. This isn't really what we're caring about too much, so we'll go through it somewhat fast. So team 11, we can remove that because we moved all of that data from cell 11 to cell 16. And then we also need to remove that respective index in our string array for when we later on make our heat map. So I am hard coding here technically, but this is more to show you guys the heat map. So don't pay attention to the hard coding. Okay, and I see 11 is empty. Hold on guys, I think my dog is whining. I'm gonna get it really quick. All right. Okay, so let's convert this to a matrix now. This code honestly isn't the best because I made it late last night. So I should have just made this a matrix beforehand. But whatever. Let's do team ID. To convert to a matrix, you do cell to mat. And I'm also going here, I'm going to transpose it as well. Okay, so now this is a matrix, and we have team by team, so we have 30 teams now, and then we have 14 years. Okay. And again, I should have really done this earlier, but I want to show you guys, really just focus on the heat map part. Don't focus on the rest here, because it's not great. Home runs by year, so let's find this out now. So I'm going to call this team home run, and we're going to look at T dot hits. Actually, doesn't really matter. Pitches, that's going to be the same as hits. In this case, they both tell us how many home runs a team had per year. So we'll do T dot hits, team IND. And now, this is going to be basically a matrix here of how many home runs that they had per year. Okay, open team home run. There we go. All right, so now let's do the heat map, right? That's the important part. Let's do that. We'll do the sorting later to show you what that's going to look like. But for now, let's do the heat map because that's what everyone cares about. Heat map. Again, if you have any questions, of course, go in the chat or user mic. All right, so we're going to do, actually, let's pull this up over here to show you what we want again. So we want a heat map that looks like this. So we have to supply an X variable. Is that their terminology? They might have called it something else. Yeah, an X variable. So that'll be all of this data here that's along this X axis. And then we also need to supply a Y variable. That's everything here along the Y axis. That's our team. And then after that, we have to actually supply all of the data that we're going to have in our heat map, which is everything inside here. So that's the amount of home runs by team per year. That's this matrix here that's called team home run. All right, yeah, I'll move you up there. Okay. So heat map. First thing that we need to do is, so there's different options here, but we're gonna first put our X values, then the Y values, then our data. So the X values, that's gonna be here, because we wanna go year by year. And then our Y values, that's going to be the team that we have, so that'll just be team. And then our data that we're going to plot, that's going to be team home run. Alright, and then let's put on a color map here, because by default it's blue, and it looks like trash. Turbo. Alright, so here we go. This is our heat map here. This is what we have by default. Well, we changed the color map, so we have year by year, and then we have all of the teams. So let's talk about the syntax again, because I'm sure in the script, and this happened to me too before, it's natural, you're going to get some errors and it might be a little confusing at first. So let's do an example for up here when we removed the these indices. So remember, we combined cell 11 to cell 16, and then we deleted cell 11. If I didn't delete team 11 here, which is actually what I forgot to do last night, so if I don't delete team 11, okay, let's run this. So basically what we currently did is here in team IND, we first deleted, it will look better like this. So we deleted cell 11, because remember, we moved all of those indices into the 16th cell in here. But for the heat map, we also need to delete that team from this string array here. So see, there's Florida Marlins right there. We need to delete them because we're only going to reference them as the Miami Marlins. So if you forget to do that, you're going to get an error. Okay, so it says number of Y values must equal the number of rows in color data. So color data, that's the data that you supplied for the heat map. So in this case, that's team home run. So if you see an error like this, what you should do, look at your Y values here. So in this case, that's team. Go in the command window and then type in the length of team. You'll see that that's 31. We currently have 31 teams here. And then let's type in, we can just use size of team home run. And we're going to be looking at the rows. And we have 30 rows here. So 31 here, the length of our Y values, which is team, that has to match the amount of rows in the data that we're supplying for the heat map. So these, they don't match up. That's because here we didn't delete the 11th team in our string array. So now if we do that, then it's going to run okay. And the same kind of issue can come up with the indices as well. Let's let's do that. Okay, and now it says this is for concatenation. So maybe not as good of an example, but let's pretend that let's say like our years were different, right? Maybe I had here like 2022 for some reason. Well, we don't have data for the year 2022 yet, so that would throw an error as well. It would say that the length of our X values needs to match the amount of columns in our data. All right, let's see if there's anything else that we could talk about for the heat map. This one is pretty simple. Okay, so let's first add on a title as well. This is related to the project too, actually. So for some of you guys, for the title in the project, you convert it to a string, which is good. You have to do that for stuff like numbers. But if you just type in string in your title, I think that, maybe I'm wrong, but I think it's always going to basically put this on its own line. So you'll see what I mean here. So let's do title. And you see how I formatted it over here on the left? I'm kind of doing it, I'm making it more readable, basically, kind of line by line. So we'll do that to you, and to do that, you can use a curly bracket that's surrounding the entire thing. So I have title and then a curly bracket, and then for each line, we have to use square brackets. So I'm going to be on my first line here, say number of home runs by team from, and I want to have a space in my title after from, so I need to have a space here. And we're going to put that. Now I want to go below. So MATLAB is still going to read this as one line of code, but for readability, I'm going to put it below here. And I'll say num to string, min of t dot year. So I'm going to say from that first year, that's going to be 2008. And then to our maximum year. So max of t dot year. T dot year. All right, and then we're going to close this first line in a bracket. And for now, let's just plot this. All right, 44. Okay, there we go. So many parentheses. Okay, so there we have our title from 2008 to 2021. And if I had string, so not numpty string, but string, does both have to be string? Nope. Okay. That's actually not even working now. So I did it similar last night. Basically, it was showing up on its own line. And I did see that this happens in the project. You know, titles for heat maps are actually kind of weird. Like you can't even use formatting for LaTeX for heat maps. So maybe this is an issue because it's a heat map. But for other type of plots, like one of our kind of regular plots, like a bar chart or a line plot, you have more options for the title, for the formatting. So if you use string and it made its own line for the year or the date, then use in your case use date string. Here I'm using num to string because in our table over here, this is a numeric array. It's not a datetime array. All right, so we'll put num to string again. Okay, now what we want to do is sort this data by looking at our very last column here. So we want to look at 2021 and let's sort it by the highest amount of home runs currently to the lowest amount of home runs. So again, this is something you need to do on your project. For the second project, you need to convert from highest to lowest for one of the plots or one of the heat maps for like percentage of fully vaccinated counties, something like that. All right, so let's sort this. So sort by amount of home runs for 2021. So to sort our data, we're gonna have brackets on the left, and we're basically telling MATLAB, here, this is going to be my sorted data. And then we're gonna have the indices for the sorted data that we have. I should say, actually top home run. And we'll say IND for indices. All right. Okay, and then we're going to set this equal to whatever we're going to sort. So we're going to say sort team home run. We want to sort these home runs. And we want to sort this by looking at the very last column that we have. So that's column 14. I want to sort our entire matrix here based on this last column where this is sorted from highest to lowest. So team home run. I want to get all of the rows for that last column. That's what we're looking at. And we want to sort this by descending. So we go from highest to lowest. Okay, and then let's comment this out for now too. I don't want that to show up. Let's run this and you'll see that this should update. Oh, well, it's not going to update because I'm creating something new here. Okay, let's open up top home run. Okay, and this is not showing everything that we want. Oh yeah, this is actually fine. We don't need all of this data right now for how it's sorted. We only need the indices for how we're sorting it. So the important thing is to look at the indices that we have. So top home run IND, open. Okay, and these are our sorted indices. So let's pop this out over here. Let's look over here. 14. All right, so here is the top home runs that we had, and then here are the indices for this column here for sorted by highest to lowest. So the highest amount of home runs so far for 2021 is 47, and then we see that our indices over here, the first one is 2, that corresponds to this index here. So this is before we sorted it. And this is the sorted indices for the highest amount of home runs to lowest amount of home runs. And then the next highest we go to, we see that's 29. Okay, they also have 47, so there they are. I guess they're sorting it first by, if it's the same number, it's going to go from whoever was originally up top. Because it's going line by line in MATLAB, that makes sense. The next one is 20. They had 46, so they show up there. 25, they had 46, so they show up there. And then look at 19, they have 45, they show up here. Okay, so we have the indices now for how it's sorted. Now for the heat map, let's apply those. Basically, we're going to do array addressing on the heat map now to have this sorted by that very last column. All right, so let's do that. So here, that's going to stay the same. But then our team, we need to apply those indices that we just found there. So we're going to say team, and then top home run IND for the sorted indices, and then same for the home run. We're going to do top home run IND, and don't run it there. Don't run it quite yet. Well, I'll run it just to show you. We get an error again. So this is because I didn't apply this for the entire amount of data that we have. I only applied it really for our first column here. So maybe it's the last one. So team home run, top home run IND. See that this is just one column. We need to do it for every single column, basically every single year. So let's do comma, colon, because remember, we're doing array addressing here. We want to use those those indices that we just found, and we want to apply that for all of the years that we have. All right, and there we go. Now it's sorted. So it's sorted by 2021 now for who has the highest amount of home runs. All right, and then if we want to go on a new line, we just, put in new brackets again, and we can continue that way. But I want to go over the first project for the code, if we have time, which we should. But are there any questions on this part? For the project, how do we do the dates weekly? You got to change the date format. Or actually for that, yeah, you need to basically, you need to modify or create a new vector for the dates that you have. So it goes by a step size of 7. So I'll leave that to you. I just told you what you have to do. Now you need to figure out how to do it though. Can I go over the for loop real quick? Sure. All right, so again, don't pay attention to the kind of shitty code here. It's not great. But we'll go over the looping part. That's what really matters. Okay, so in this loop here, I wanted to find the indices for each team that we have. So when do they show up in our table T here? So all we have to do is look at column 2. That's called player ID. That stands for the team. And we want to look for when each team is going to show up. So if I go for the first team, that's like Arizona, I think. It's currently sorted alphabetically. So it's going to find when Arizona shows up, and then it's going to loop through and find when our next team shows up, and then our next team, and then our next team. So let's comment out everything from here right now. Let's go. It's so slow to comment stuff out in MATLAB. All right, let's just run this here. Team ID. So currently we have this. Actually, can I modify this? Yeah, no. Okay, never mind. So we have team IND. So this is the indices for each team. And then, so we have 31 teams right now. But really, we want to do this where we have this also just for 30 teams. Because remember, we took out, or we put team 11 to team 16. And we did some concatenation. So then we fixed that. So it was 30. So yeah, and then down here for cell to mat, this is going to modify everything so we can convert everything to a matrix. Try this again. And then if I go to team IND, now we have what we just had before, which is just a cell array. and then each one had 14 values in there. Now we made it a matrix. Really, this is kind of, again, not great code. I should have already made it a matrix in the beginning. Okay, but does that make sense? We're just looping through each team and finding their indices. So when do they show up in player IND here? And then also for the project, another comment for the write-ups. When you guys go over this part here, when you find the indices, a lot of you guys didn't explain what was really going on. So the indices, you got to make sure if you have a function, you got to explain what the function is doing. And if you're using something like logical indexing or a logical operation, you need to explain what that logical operation is doing. So in this case here, you got to explain both what find is doing and what this logical operation is doing. So you should say that the logical operator first is going to give a value of a 1 or a 0 for when or for if a team shows up in each row in our table here. And then the find command is going to operate on that, and it's going to give us the actual rows or the indices when that was true. So just make sure you do that. Basically, if you are wondering like when do I talk about what or how much detail, if you're using a function, talk about it. If you're using a logical operator, talk about it. The array addressing, talk about that too. So go over dot notation. You don't need to do it for every single time, basically in your write-up. So here I use dot notation for the first time. I'm looking at the column called year in our table. So this shows up the first time. In my write-up, I should explain I'm using dot notation to access a specific column in our table. So you mention it that first time it shows up. You don't need to mention it again because now the reader knows what dot notation is. And same thing with array addressing. For each kind of unique type of array addressing, you should talk about it at least once. So here, let's see, array addressing. We have array addressing right here. So this is looping through, the first team, the second team, the third team, the fourth team. Talk about the array addressing here, and then down here you should talk about it because not only are we doing array addressing for a vector, but here we're doing it for a matrix. So you should say, we have a colon here. That means get all of the rows, and then comma ends. That means get the very last value in that specific row. All right. So any questions on this again before we continue? Go on project 1. Okay, so I'm gonna talk about project 1 first. I remembered. I'll talk about the grades. Okay. Oh yeah, SOQs. So SOQs, guys, don't forget about them. They're due on by the 14th. What I did is I didn't do anything. Yeah, okay. Okay, there you go. So the SOQs, you should have got emails about them. I think they're like spamming the hell out of you this semester. So click on the link in the email if you haven't already done the SOQ for this class, or you can just log in on the school's website, and on the main page, you should see an SOQ kind of link directly on there, and then you can do the SOQ for this class. So, please do them. They're due by the 14th. I'll send out another reminder. I can see how many people did them too, which is actually pretty nice. I couldn't before. And there's not too many so far, so make sure you do them. Okay, if you got an error, it's most likely, I'm just guessing, it's something to do with your parentheses or maybe your dots here. You need to have a space before the dots. So it's probably a small thing like that. But based on your error, I don't know for sure. I'd have to look. But it's most likely something with parentheses. Okay, I'm going to stop sharing really quick because I want to talk about some comments on Project 1, and I have them in a different window, but I don't want to accidentally show anything about any specific student if I have anything. Okay, so I think I talked about most of this already, but so dot notation, remember you got to go over that. You need to go over array addressing, and then let's see what else. Explain why you used a cell array if you used one, and then explain why you converted some columns from a cell array to a string array. So I did talk about everything. Cool. All right, so now we're going to do project 1 then. We're going to write the code for that. I don't know if we're going to have enough time to finish it today, but we'll see how far we get. We might be able to. Okay, I'm going to close out of this now. If you guys want to see the script again, you can let me know after class ends. All right, so I think I have it open here. Yeah, I guess I can use MATLAB. Okay, fine. I really don't like MATLAB's interface. I really prefer typing in here. Okay, let's make a new script. I'm gonna copy and paste some things again, just the things that we know what to do. Okay. New script. Project 1, code, class, clear, CLC. Make sure you guys put it in clear and CLC. If you don't, it gets a little annoying on when you run your scripts, and really it increases the possibility for an error. So just make sure you put these at the top of your script. Okay, so here all I did, we're importing the data, and we're also sorting the rows here. Let's make it bigger really quick. So we are importing the data, and we're sorting the rows. I'm gonna have to put the data in this folder. Actually, what I'll do, I'll just put it in the folder where I had everything, not this class. Oh, I spelled the class wrong. Okay, so we are importing the data and we're sorting it. In this case, for the vaccination data, I'm sorting it by the administered date. So this is going to be from the first date to the last date. And then for the population, I'm sorting it also, and I'm sorting this by the amount of population from highest to lowest. And so I'm doing that because, we want to reference the top 5 most populous counties for all of the figures. So if I sort it by those, by the population, all I have to do is do array addressing for the top 5, and then I can get their values for the population and also the county name itself. Okay, conversions. So, how I have the comments here, this should be, something similar to how you have it in your report or for your code. So conversions, converting some of these to a string array. I'm not saying it here, but in the write-up, I would say that we're doing that because we need to convert these counties to, or these columns to a string array, because later on we're going to be using a logical operation. Okay, and then a reference variable. So we have one for the top county. So I made one called top, that's equal to 5. And we have RA for rolling average, amount 1 million. If you didn't make this variable, I didn't mark you down for that, so don't worry. And then here, vac range, this stands for the range of dates that we have for vaccinations. In this case, that's looking at the very first date that we have in our table, and then we're going to the last date. So I use the max function for that. And the last D here, that's just going to be the very last date for the vaccination. So I'm going to use this kind of as array addressing, Actually, not array addressing, it might just be in the title later on, for the last day of vaccinations. Okay, so first thing that we got to do after all of this is find the indices. Oh yeah, let's actually show you the sorted data sheets. Let's open up VAC and let's open up POP. Okay, open VAC, open POP. Alright, so vaccinations, this is sorted again by date. So we start off on December 15th. And you see that well, you can't really see it here, but not every county started on the 15th. So that'll be something that you got to be wary of in Project 2. Okay, in this one, this is our population spreadsheet. I sorted this by highest to lowest for the population. Again, so I can just grab these top 5 counties here. I also, what you have here, the counties here, they're different than all of the counties that show up in this spreadsheet. All of the counties in here do show up in the vaccination spreadsheet, but the vaccination spreadsheet contains more counties. So if I type in unique of t.county, or yeah, not t, I usually use t, so fact.county, you see that there's one that's called unknown, and then we have outside of California, and then we have these two up here. All right, so be careful of that, because some of you deleted, you were looking at the indices in here for counties that you want to delete. You shouldn't have to do that anyways. If you wanted to delete the counties, basically you should say, kind of do array addressing for delete the counties that aren't in the top 5 or that aren't the top 5 counties, and then you don't actually have to type out each row that you want to delete. Okay, but some of you are looking at this spreadsheet here for these indices, and then when you deleted those, you were deleting them from your vaccination spreadsheet. But again, the counties are going to be different because we have like these two things here, and we have like outside of California. So you actually ended up deleting the incorrect county, so your graphs were wrong in the end. So be careful of that. Make sure you run your code again and that it looks right. Especially do it right before you turn it into. Okay. I have a feeling we're not going to be able to go over everything. So we might finish up then on Wednesday. Probably do that. Alright, finding the indices for county. So biggest thing, right? We got to find the indices for all of our top 5 counties. So let's do top IND. This will be for our first county. And we're going to say find when vac.county equals pop.county. And here I'm going to put 1. So I want to find all of the indices for our very first county, our most populous county. In this case, it's going to be LA, but don't write out LA indices. What if later on, I know it's not going to happen in the length of this class, or it's going to be a really long time, but what if another county became more populous than LA? It's not going to be LA for number 1 now. It's going to be something else. So keep it generic. Just say something like top IND. And here I'm saying that this is going to be our first column in this matrix that I'm going to build. Okay, now let's do this. See, I don't like typing stuff in MATLAB here. It's slower. So let's do this for all of our counties. That's 5 of them. Of course, it sucks when you can't loop. Let's run this and then let's look at top IND. Alright, so here we go. We have the indices for all of our top 5 most populous counties for when they show up in the spreadsheet called VAC. Also, you see that I used regular parentheses because the length or the amount of indices for all of these 5 counties, they're the same. So I can use a regular parentheses, put them in a matrix. Okay, next thing, we can already solve for some of the things that we want to look at. So first one is going to be the cumulative doses that we're looking at. And here, you'll see, it's probably hard to see on your screen, but it says by million. It's not per million. Basically, I'll get to it later. Don't worry about it for now. So let's do top, or cumulative doses rather. So cumulative doses by population. So we're looking at the top 5 most populous counties. And this was our first bar chart that we had to make. So total doses, cumulative. I want to do this for the top 5 counties. So this is going to be a row vector in this case. We have 1 row, and we have 1 to top rows, and that'll be 5 rows. All right, let's do vac dot cumulative total doses. Very loud. Okay, so we're looking at that column, cumulative total doses here, and basically what we want to do is we want to get the last index for each of our top 5 counties, and that'll give us directly the amount of cumulative total doses that that's currently given for that county. All right, so we're doing array addressing here. So we have our indices already. So let's do top IND. So that's going to look at all of our indices here. But I want to do this for the very last index for each of those counties. So we're going to say end, and we want to look at this for all of the counties. So that's from 1 to top. Okay, so let's go over this one more time. So I'm specifying that we're going to make cumulative total doses here. This is going to be a row vector. We have 1 row, and we're going to have 1 to top columns. That's 5 columns. I'm looking at the cumulative total doses column here, and we're using array addressing because we just found all of the arrays for our counties. So we're doing array addressing. So we're looking at those arrays top, or those indices, top IND. And for each one, I want to look at the very last index, or the very last row. So we say end. So don't type out the row manually. Some of you did that too. Use the end command, because as we update the spreadsheet, you don't need to do that manually. You can just say end, and you can just run your script right away. You don't need to change anything at all. Okay, so that's the last row. And then we want to say 1 to top. That's going to be for the 5 counties that we specified here. All right. So let's run that. Open up total doses. And there we go. We have the cumulative amount of total doses for our top 5 counties. So this, this is only 1 line. It's not 5 lines. So that'll save you a lot of time too. And let's say that we had 6 counties, right? So we had 6 counties. Change this to 6. Maybe I'll actually move this down here. And we'll say top. It's the length of top IND. And we want to do that for basically for our 6 counties here. Okay. I don't know why I'm having a brain fart here, but we want to do it for the amount of columns that we have. So 6 counties, okay? Let's run this now, and now this is going to update. So we have our 6 counties here. And that's it. I didn't have to make a whole new line. All I had to change was just I found the indices for that, and then we changed top. That should be basically the length of top IND for the amount of columns that we have. Actually, we could do look at top IND again. This could just be the width of top IND. Width of top IND, and that should say 6. It does. So that's looking at basically how many columns we have. Let's do this actually, make it a little bit better. Okay. Suppress your code too. This isn't suppressed right now. Let's suppress that. If you don't suppress your code, some of you did that, it also makes your script a lot slower, especially if you didn't suppress this block of code here for the indices, it would Just it would have a ton of stuff showing up in the command window. It'd be really slow. Okay, so there we go. Next thing, or let's show this plot now. So what I would recommend is actually just putting all of your plots together at the end. But for sake of time and demonstration here, let's show this plot. So we're going to do bar total doses cumu. Okay, this is why it's also better to have whatever data you're looking at, put that in its own like matrix or its own array. And we can just do that, and there we go. We have our bar chart. So here, I added another county. And now let's do this. Let's add on some stuff. So we're going to do AX equals GCA. Let's get rid of those exponents. You should be putting in some comments here. But let's do AX equals GCA. AX dot y-axis dot exponent equals 0. Okay, we still have that there, so we need to change the ytick format. Ytick format %0f. That'll take out the exponents on the side there. Let's add in our Xtic Labels. And so for this, what are we going to do? We're going to use array addressing. We're going to look at our population spreadsheet. I want to get these top 6 counties here. So that's what we need to do is pop.county. So we're looking at the population spreadsheet pop, looking at this column called county. And I want to do from 1 to top. And then we have our counties here. And then we can do an angle if we want to have an angle, and that's all good too. Okay. All right, next thing. Yeah, okay. Yeah, top 6. Okay. So next thing we're gonna, I'll just delete this for now, who cares? We're gonna do the % of population for cumulative doses by manufacturer. Manufacturer, and this is A.2. That's the second bar chart that we needed to have. So let's first group this by manufacturer. So we're going to have an array for each manufacturer. So let's say manu perk pop. Okay, yeah, I should have had a comment really. Let's do Pfizer first. So Pfizer. Okay, so I'm saying menu perk pop manufacturer % of population. Okay, here I'm going to have 1 to top amount of rows, and then I'm going to have 1 column here, and this will be for Pfizer. So let's go to vac.cumulative Pfizer doses, and we're doing what we just basically did above. It's the same kind of idea for the array addressing. So top IND, and we want to get that very last value because we're just looking at the cumulative amount of total doses for Pfizer. So and then 1 to top. All right, and then we want to now divide this. I'll do some dots there. We want to divide this by the population for each county. So that'll be divided by pop.population, 1 to top, and then we multiply it by 100 to make it a percentage. Don't forget to do element by element division, because we're not doing matrix division. We want to do element by element. Let's I'll comment that out just so we look at the top 5 counties. All right, open menu perk pop. Here we go. These are all the percentages for the top 5 counties for Pfizer. Now we do this for Moderna, and then for Johnson & Johnson. Okay, Moderna. And this is nice too, because all I need to change is we'll make that a 2. This will be our second column. And this will be our third column. And then we just need to change this to say Moderna. And this to be JJ. And now we have our other two columns here. And, you know, doing your code really concise too, that'll help you or motivate you to, or you have motivation to write your code more concise. So you don't need to have as long of a write-up too. Think about it that way. All right, I guess I'll do the plot here too right now. So bar, menu, perk, pop. And with how this is, you know, we're plotting a matrix here. So this, I might need to transpose it. I always forget. Okay, I don't. So this is already grouped by, basically by county. It's looking at our 5 rows, and then it's going column by column. So, you know, our first column here, this is for Pfizer for all of our 5 counties. All right, so there we go. If you guys got this, it should look like this for when you did it. And then, let's see, next thing we want to do is the percent, or not the percent, we just did that one. Oh, okay, yeah. So the percent of the population that, percent of population for the cumulative amount of doses that we have. How many people for each county have received a dose? It's, I think I said this before, it's not really a great plot here because it should be something like for 1 dose, at least 1 dose, or fully vaccinated. But whatever. Percent of pop for cumulative doses. Okay, this is total doses per pop. So total doses, percent of population. We want to do this for our top counties. And this can just be a vector. Okay, so that's going to be total doses cumul. We already made that up here. That's looking at the cumulative amount of total doses for our counties. So we already have that data, but now we want to divide it by the population. Oh, this is also per million, I guess. Is it? I forget off the top of my head, but right now I'm going to do this per million. I forget. Oh, I see what I did actually. I think. Okay, let's just, I'm going to type out what I have here and then we'll look at the plot. I made this code a while ago. So pop.population, and then we want to multiply that by 100. Want to look at our top 5 counties, so that's 1 at the top. Okay, did I suppress this? No. Open total doses per pop. Here we go. So yeah, no, I don't know why I have you in there. Okay, that's correct. Oh, I know why. My code's a little different from what I did something earlier in my code for down here. So these are the percentages. If you got this plot right, you should see that this is familiar. So we'll do bar, total doses, perk, pop. And you should have seen something like this. And then of course we do the same thing as before for the Xtic labels. We would reference our population spreadsheet, look at the county column, and then get the top, in this case 5. All right, let's move on to the line charts now. So amount of people or persons with at least 1 dose per day per million on a 7-day average. There's a lot of stuff. Okay, so we'll call this 1 dose. Okay, 1 dose. We want to get all of the rows now because we're doing this day by day. So we want all of the rows and then 1 to top column. So column 1, that's going to be day by day for like LA. Column 2, that'll be day by day for San Diego, and then so on. Okay, we're going to do mob mean because we want a rolling average. Some of you didn't talk about the syntax for mob mean. Make sure you go over the arguments that you needed for mob mean. That's your data that you want to work on, and then the length for the rolling average, or the amount of days, and well, days in this case for the rolling average. Okay, so vac, we want to look at the vaccination spreadsheet, and then go to vac, at least 1 dose. We need to use array addressing again. So we want to do it for our top 5 counties. So top IND, we want to get all of the rows now for each county. So that's all of the rows, one to top. Go on a new line. And then we're going to multiply this by amount, which in this case is 1 million, and divide that by the population for the top 5 counties. So that's 1 to top. I have to transpose this just so it's the correct dimension for dividing this. And then rolling average. That's our rolling average that we're specifying. That's in this case 7. Let's run it. Let's open this up. Open one dose. Here we go. So we have 129 rows, because that's how many days we have, and then we have our 5 columns for each county. All right, so let's plot this one too. Let's make sure that it looks good, because we have like no time left. Is there a space here? Yeah, okay. So let's do plot one dose. And then there is our plot. So, and then the other things here, we have amount of persons that are fully vaccinated per day, and then the total amount of doses given per day. That's using the same exact technique as we just did here, so I won't go over that part. It's the same thing, but let's add on some things here. XLM. You guys need to use XLM so you don't have these spaces in the beginning and the end. Also, this should be the days here, so that's day range. Is that what I called it? Vac range. Okay, so vac range, comma, 1 dose. So then you have your dates. Now we need to get rid of those spaces. So let's use XLM. And this will be, let's just do min of vac range. And then we're going to just say max of vac range. Max vac range. Okay. There we go. And now we don't have the white spaces. Let's add in the legend. That's going to be, I hate when that pops up. Pop that county 1 to top. Okay, here's our legend. You would obviously specify the location. And I know we're out of time, but let's put in our title as well. So this will be at least 1 dose. Okay, I'm going to make a really long title here just because we're out of time. Per day, per million, top 5 counties. God, this is bad. Really long title. 7-day rolling average. And then up to date string. Oh my gosh. Date string of, what was it called? Was it called the last day? Last underscore D. Okay, let's close that out. And so you would not do this. If you were going to have a title this long that looked like this, you would probably get marked down, but I ran out of time. So your plot should look something like this. All right, so that's it for the code for project 1. If you have any questions on it, you can ask me. I know I had to go over it kind of fast, but you can watch the video again if you want to understand anything a little more too. All right, so that's it for today. So I will see you guys on Wednesday. Make sure you're working on the project. I'm going to send out an announcement like I said I would before for any questions you have on project 2, and we'll field some of those questions on Wednesday. I'm not going to give you the answer straight up, but we'll talk about it. All right, so I'll see you guys then. Good luck on the project and good luck with the finals.
Thank you, Professor. Have a nice day.
Thanks, you too.